All right, welcome everybody. My name is Raman Pranjapit. I'm the Associate Dean in the Faculty of Engineering and Applied Science. Today we are starting the second in a series of seminars and symposiums that we are organizing focused on decarbonizing Southern Saskatchewan. Today we're focusing on transportation and methods and approaches that can be used to reduce the impact of greenhouse gases that are emitted due to transportation. Our speaker today is Kelly Tang. Kelly is a relatively new professor in our faculty. She's in the Environmental Systems Engineering program, and we're very, very pleased to have her with us. Kelly did her PhD, I think, at the Science and Technology University in Hong Kong. She has experiences as a postdoc at Berkeley and I think Technical University of UC Berkeley, but also Denmark, is it not?
Yeah. University of Denmark.
As I say, we're really pleased to have her as part of the engineering program here. She was recently very successful with a NSERC Alliance grant. I think it's around $750,000 focused on this area. So I think with that, I will hand it over to Kelly. She's going to talk to us about EVs and the solution and some of the issues around adoption of EVs. So with that, Dr. Tang.
Thank you, Raman. Good afternoon, everyone. It's nice to present the challenges research and the potential strategies that to decarbonize transportation. And so I'm the assistant professor in environmental system engineering in the Faculty of Engineering and at the University of Regina. And before we starting with the topic, a good question is that what is transportation? So when you think about transportation, what is the first word come in your mind? Vehicles.
Getting around.
Getting around. Mobility. Traffic. Gasoline. Congestion or travel or going to the essential services, commuting, go to work, come back home. So all these activities around to move people, move goods around, that is falls in the domain of the transportation. And transportation as a sector that in Canada serves as around 1/4 of energy and emissions. So here is the two facts that at the year of the 2019 published by the government of Canada, that transportation is one of the largest greenhouse gas emission sector. And the main reason is what we have already identified at the beginning, that transportation is associated to the for many of daily activities, for the people's travel, for the goods travel, for the goods transportation, logistics, supply chain, and all these are counted as part of the transportation activity. And transportation that we're really looking at a passenger transportation or freight transportation. So passenger transportation, the main modes is like road transportation, every day we drive. Air transportation, we fly to a long distance destination. Rail transportation, which is another alternative mode for a long distance or short distance. Freight transportation is more related to supply chain logistics to move the goods to the different cities, to the remote and urban areas. And this also on top of the rail, road, and air. This is also a marine, which goes through with the water that travel between continents and between the countries. So the left-hand side is end use of the demand, energy demand by the sector, which we can see. The first is industrial, that is more related to the industry activities or the goods, and the second is the transportation. And the right-hand side is a figure that is a GHG emission, or we call greenhouse gas emission, by the economic sector. And transportation is one of the major sector that are considered, also including the other sectors like electricity, agriculture, buildings, waste, oil and gas, etc. So the high demand and activity in transportation intuitively induce the high emission. And the next question is that how can we address these emissions? When we answer this question, a very important thing is to understand where are these emissions come from within transportation sector. So this is the graph that as of the year of 2014, that for the different mode of the transportation. And what we can see, surprisingly, is that passenger light trucks has increasingly demand over the past years. That is to say that passenger, or can be counted as all of us as the passenger, that people have a trending to purchase a larger private cars than say 10 years or 20 years ago. And larger cars will means a larger or higher emission for that. So then this comes to an issue is that what can we do to reduce the emission, and in the meantime to also accommodate individuals' demand, that to create a beneficial strategy to both the environment and the individual people. When we looking at decarbonization pathways, so we still look at passenger transportation or the freight transportation. So in passenger transportation, we look at three major modes. These three major modes can be categorized as the active transportation, which, for example, walking, bicycling, e-scooter, or those that non-motorized transportation mode. So at the city of Regina in the past years, that the city has also built it or increased the bicycle lanes or bicycle infrastructure. So this act as active action that to promote active transportation, that to help people shift their mobility mode to a more sustainable and more environmentally friendly transportation mode. Then the second comes to the public transit. Public transit is a way that provides essential services, especially it is critical to many of the citizens or people who don't have other choices or who cannot own a private vehicle. Then public transit serves as an essential way for them to move around, to access essential services, clinic, food, or the other entertainment or public services. So public transit has been also in like one of the major transportation mode in many of the countries. In Canada, our major mode is a private car. So Canada has about 70% of mode share for the private cars. And this comes to a straightforward pathway is that if we want to decarbonize transportation, we want to encourage people to shift to a more sustainable transportation mode or travel mode. And on the other side, however, that we know that people have a demand. Private cars are essential for us to travel to work and to go to many other services because of the infrastructure in Canada is built on the promoting usage of the private cars to provide convenience of private cars. And then this comes to a pathway that how can we improve the active transportation infrastructure, like build more bicycle lanes? How can we improve the public transit infrastructure, like improve the public transit services, optimize the schedules, provide more accessible public transit stations to both remote and to both urban areas. So this is from the perspective of the infrastructure side, how can we encourage people to shift from motorized mode to a non-motorized mode, so that to modify the travel behaviors and to encourage the demand goes to a more sustainable way, and as a result, reduce emission. And the second part in transportation, as I mentioned before, is a freight transportation. So when we look at the freight transportation, I categorize into two parts. One part is what we look at is a mass transportation mode. So that is those transportation provide a large amount or large quantity of the supply chain, such as railway, such as the marine. Those transportation mode serves as important part in the freight transportation. And on the other side, that is a medium to heavy duty vehicles that are providing the services to transport the goods for the intercity or between provinces. And that's also commonly what we say, those trucks that provide the freight services. And in Canada, truck mode share account for about 90% compared to the other freight transportation mode. And so here it comes to a point or a critical issue that we want to look at, is that when we are on the pathway to decarbonize transportation, how can we create a strategy, and also how can we reducing the emission and in the meantime accommodating people's demand and accommodating the current fact that although we want to encourage a shift to the active transportation, public transit, we still have a large amount of the demand that are heavily rely on the private cars or heavily rely on the trucks, those vehicles. And here's come to a thing that electrification of the vehicle are one of the key pathways. Electric vehicle is not the only pathways, as we identified before. There are a variety of the pathways to decarbonize transportation. Electric vehicle can serve as a key pathway along with the other pathways. And now it comes to a second quick question, is that when it comes to the electric vehicle, what is the first word come to your mind? Electricity. Because Gary is working in the electricity research. And what else? What the first word come in your mind for the electric vehicle? Charging. Charging.
Very expensive.
Very expensive. So electric vehicles, I say electrification, electricity, that we need to charge it, that as individual passenger or a user, end user of the electric vehicle, the thing is that how can we charge it? It is convenient for we need to charge it. What are the additional expenses that we need to pay for charging? And this could include, we need to install the home charging stations. And then I might also need to consider what are the mileage that we can drive in the electric vehicle. And all those comes to interactions of how people are going to travel when we buy or when we're using electric vehicle. And what will be the demand and what will be the overall market that when electric vehicle, when their policy to promote the electric vehicle. And ultimately that because of its energy resources belongs to the electricity, what the impact it will be on our existing electricity usage. And ultimately that electric vehicle, the essential goal for adopting this is that we want to mitigate the greenhouse gas emission in a way that it can reduce the global warming and also can promote a more sustainable society. So today's symposium, electric vehicle that covers a variety of the sectors. So the issues to look at, or the challenges that to look at electric vehicles, as mentioned, covers electricity, covers travel pattern, covers infrastructure. So today's symposium, I will focus on the travel pattern, demand, and transportation infrastructure, how these are interacting with each other, and what kind of challenges we have for the travel demand, and how can we promote or create strategies or a win-win strategies that can provide a plausible pathway to both as an individual passenger and also to the service providers, and ultimately to mitigate the greenhouse emissions in the society. And in May 25th, that we will also have a symposium that looks at transit, active transportation, and electrification's perspective on decarbonizing transportation. So when we look at the electric vehicle, it's good to look at a global picture, or what we say, a policy, a macroscopic level. This is a graph that is showing what will likely be if we are keeping the same pace of the current electric vehicle adoption. So globally, many jurisdictions have agreement for the 1.5 degree to kind of control the 1.5 degree global warming in the next 20 to 30 years. And electric vehicle as one of the key factor, if we're keeping the same condition, and this is what we're going to be at 2030. And however, if we want to achieve our goal globally, that with multiple countries' effort, then this is what we would like to have by 2030. So with the current actions or practices, we will be halfway of what we want to achieve. And that's one of the reasons that some of you, when you're in the sector or you're in the relevant field, you may feel that in the past 5 years, especially in the past 2 years, many of the government or many of the jurisdictions that have launched or released more progressively strategies and policies for electric vehicle adoption, and also for the greenhouse gas emission actions. So this is globally with several representative jurisdictions. Then let's look at back of what is Canada's profile here. So Canada has a mandate. We made a mandate that by 2035 to achieve 100% of zero emission vehicle market share for the new light duty vehicle. So when we look at it, when we say new light duty vehicles, that means the private vehicles or semi trucks or pickups. Those are considered as new light duty vehicle. Zero emission vehicle, although it's not exactly the same as electric vehicle, zero emission vehicle is more considered like hybrid vehicle, semi-electric vehicle, or electric vehicle using the hydrogen cells. But electric vehicle still is a major part when we consider zero emission vehicles. And in Canada, this is the table that what will be the expected EV in circulation by for every 5-year term. And this is what will be the expected total charging infrastructure if we want to achieve this goal. And this is our current facts that initially we're kind of at the range of 2020 to 2025. And we're expecting to have about 200 to 1 million kind of EVs in circulation. And in 2021, we have 68,000 electric vehicles registered in Canada. So, and on the other side is that the total charging infrastructure is supposed to be at around 50,000 to 180,000 level. And by the year of 2022 May, we have about 16,000 chargers at 6,000 public stations. So in practices, we are still far from what we want to achieve. And then that comes to an action is that how can we accelerate the process? The first question we want to answer is, do we want to shift to electric vehicle? And when I'm saying we here, it's referring to a public or a market or a demand saying that is a public want to shift to the electric vehicle. And the answer is yes, if we look at it based on the shares of electric vehicle in the total new vehicle registration. Although we kind of still at the low absolute value level of the electric vehicle registration, but there is an increasing trend. And we see this increasing, we see this rate of increasing also changed in a way that it's kind of at a similar exponential rate to increase this electric vehicle registration. And then this means that we have sufficient demand and that the public and many of the passengers are willing to purchase electric vehicle and use it. Then the next question is that now we know that there is a demand here and many people are willing to buy, to use electric vehicle. The next will be, is our infrastructure ready? When there is a large demand, then there will be a large usage of electricity. There will be large usage of the charging station. There will be also large usage of the road infrastructure that related to the electric vehicle. And a follow-up, the thing that we want to answer is that what can we do? And this we here refers to the service providers, refers to the policymakers, which some of you may in that domain. And then in the sense that how can the service providers, this service provider could be electricity providers, the service providers could be the commercial companies providing the charging stations. And the service providers could also be the Ministry of Highway that providing the essential infrastructure, the accessibility for the road users to access the EV facilities. And in that sense, what can we do to improve our infrastructure and also to provide a feasible infrastructure and convenient facilities to accommodate increasing demand, which we can see that in the near future, we could have a high increase or large increase of electric vehicle in the next 5 to 10 years. And here comes to the challenge is that, so first of all, transportation sector counts for is one of the largest emission sector that we want to solve. But however, that when we have a large demand, look at a national graph, is that in the Prairie region, we have about less than 6% of electric chargers that count for all the national chargers in the across west to east. So this will make or induce some issues for a long trips. And as what we can see before, that private car is one of the major mode share in Canada. And in Canada, that long distance trips are also long distance trips are also sometimes essential for not only passenger vehicles, but more importantly for the freight vehicles. And we have a large or a wide freight road infrastructure. Those truck drivers that when we go through the electrification of the trucks, that they do need a high accessibility to the electric vehicle facilities. So this includes electric vehicle chargings. It also includes how the electricity or the robustness of this electricity supply. So when this comes to one of the challenges for the long trip across the provinces and also across the regions. And another challenge that when we look at the long distance challenge, we look at in an area where there are less electric chargers. But however, that for the areas, also for the regions, when we have a dense or when we have densely populated area, or also that when we have a variety of the electric chargers, it comes to a question that there could be a charging queuing. That when people go to work, when they're commuting, instead of that add a fuel that which takes 2 to 3 or 2 to 5 minutes, that now that they probably need to stop by a charging station and stay there for 20, 30, or sometimes could be 1 hour. And this charging queuing can become a major concern for the urban EV travels. And that is to say that if we want to achieve our mandate by 2035 for net zero emission vehicle, then this will need collaborative actions from different sectors, and we need to create cross-sectional strategies that comes from travel demand, comes from transportation sector, and comes from electricity sector together. And let's look into more detail of why that long distance trip that can be a problematic issues which can be, and which we need to address it to consider people's travel demand and also to consider people's travel patterns that is actually different from the passenger vehicles and different from the freight vehicles. So this is a charging map that's in the North America, and the blue charging station indicate level 2 charging time. Yellow charging station indicate level 3 charging time. And later I'm going to explain more in detail what are the difference between the different levels of charging type in the consideration of the charging time, cost, and also the charging power. But now in here, now more focus, we want to see what is it. This is uneven distribution of the charging. And if we see that majority of the charging station and also level 3 charging station are concentrated in a Vancouver area, BC area, or in Ontario and Montreal, Quebec area. And if we were able to open the website, then we can see in detail in here what we are having in Regina. So we do have a variety of the level 2 charging station that are more distributed in our major lane. However, the thing will happen is that if people who is living, let's say in the north region, and they want to charge, and there will be only one charging station in the north region, and they might need to travel to the downtown area, get the vehicle charged, and back to the north region. And from the perspective of travel demand, it will be that it will create additional trip. When it creates additional trip in congested area, it will create a more congestion. Although our city doesn't have too much congestion, even in the commuting area, but this could be a future trend that we can observe if we are keeping the same distribution of the infrastructure here. So this is the inner city charging consideration. And let's zoom it to a larger graph, is that when we consider we travel it from Saskatchewan to Alberta or to the nearby province, our major highway infrastructure do not have adequate charging station. It's distributed sparsely among our Prairie regions. And if we look at BC area, the density of this charging station is much higher than the Prairie regions. And so that is to say is that if people want to travel across the west to east, they will face a charging bottleneck within our Prairie region. And that will, especially for the freight or logistics or supply chain, and that will also create, let's say, the delay of the goods or delay of the supplies or essential food to some of the communities. So long distance trip is more focused on the uneven distribution or lack of charging stations. And when we look at some regions for an urban trip, so this is a video that one of the EV users posted to Twitter in February 2nd, 3rd, which is a winter time. And this is the lineups at a Misago supercharger. And we can see from the video that there are at least 10 to 15 vehicles in front of him. That means that he needs to wait here for at least 1 hour. And this is a supercharger. And when we say supercharger, it means it's charging type, which is L3. And so here it comes to some more detailed statistics, the different level of the charging station. So L1, when we refer to the L1, is a charging power that has the lowest and yearly, but is more economic convenience for residential installment. And it can be compatible with the current residential electricity power. With L1, charging a Nissan Leaf, that is a kind of medium or low mileage vehicle, electric vehicle, will take about 30 to 40 hours. So if you have a Tesla, this will take about 90 to 100 hours. And so that means that it's almost impossible for the L1 to fully charge, but also in practice that when you get an electric vehicle, it's likely that users will charge when it's really out of battery. So most of the time we'll charge it on the half of the way, or we charge it when we feel like it is time to charge. So this also indicates a different travel patterns for users when we change it from gasoline vehicle to the electric vehicle. When we having the gasoline vehicles, we are not that worried about when we have a less fuel in the vehicle, and we probably at the minimum level that we go to fill up our car. But for the electric vehicle charging, we observe that users tend to charge it maybe at 50% of levels, or at 40% levels they want to charge because they don't feel safe in a way that the battery can support them to travel for sufficient mileage. So L1 type now currently is generally not implemented in public stations or commercial centers. And as what we can see in the map, most of the commercial centers or charging station that we were adopting L2 and L3. And here comes to the trade-off between the time and the expenses. Even we still see the map here, majority of this charging station are L2. And this is because installation cost for L2 is about 6,000. L2 will need about 2.5 to 4.5 hours to charging full to a Nissan Leaf. And if we want to choose L3, it will sharply reduce the charging time, but in the meantime, it will have 10 to 20 times of the installation cost. But also, of course, that battery technology is improving. So we also observed a battery technology improving will reduce the charging time and will also reduce installation cost. But at this kind of early or medium stage, we are still in the transition way, which we are facing the choices of if we want to choose a charging station which is have a less charging time, we want to choose a charging station that has a less installation cost. And this will give a question that to the service providers. And then they need to look at the trade-offs, benefit and the revenue of which charging station they want to install in the commercial area or in the public station. And also that, however, in the charging type L3, we will still need 30 to 40 minutes, which is compared to the gasoline vehicle fill up, is still a large amount or a large increase of the time. And that gives the reason that why there will be a long queue at the supercharger station. And this is a typical working day and in their commuting trip in there. So this means that when we really look at a large or scale up EV adoption, we might need to understand how people travel, especially when and where people want to charge their cars. And this can be different or at the opposite side of the strategy compared to the long distance trip. In the sense that when we look at the long distance trip EV charging infrastructure, we want to provide in a place that is accessible, that is convenient, and that is easy to find for the truck drivers or for the passengers. However, in the urban trip, if we want to avoid congestion and if we want to consider those charging queuings, we might want to distribute it in the area that it didn't reduce additional congestions on the road. So that is to say, for example, we might not want to put a urban charging station in a busy shopping mall, because busy shopping mall already many people are traveling there. And then if people are running to queue there for charging, that will create a congestion, additional congestion for the traffic flow goes to there. Or instead, we might want to put it in a nearby area, which we consider the balance between the convenience and also the balance between the congestions. And this is very important in many of the urban cities and areas. And although in Regina that we don't have a long queue or congestion, but we do see an increasing car registration in the past years. And we cannot really mitigate the possibility that maybe in the future, one day, we're going to see a queue that in some of our regions in the city as well, because of the increasing vehicle demand, because of the increasing population and economy that in the province and in the city. So then here it comes to the strategies that what we can look at to create a palatable way, to create win-win situation, or find feasible pathways that can bring the benefits to individual passengers like us, which can also bring the benefits to service providers in a way that it can provide sustainable finance of the EV infrastructure, and also and ultimately that reduce the mitigations for the environment, for the society. So I categorized three major domains. That's first one that we might want to first look at what are the travel pattern change and how the increasing adaptation of the electric vehicle will change the travel patterns, the traffic flows, the queuing congestions in the densely populated area. And the second will be, how can we design a long distance EV travel and road infrastructure to provide sustainable and robust supply chain and freight services that can still keep the same level of services for our Canada supplies and can provide a timely delivery that to the cities and to many of the communities. And the third part would be understanding when we categorize, when we understand how people travel, ultimately a large adaptation for the electric vehicle will going to affect our electricity usage in the residential area or in the commercial area. And that comes to the electricity sector. So the electric vehicles, it is a cross-sectional, I would say, a topic that will need a collaborative effort and need a collaborative strategy to be designed together. And all this solution come together will help us to identify how the electric vehicle penetration can mitigate the greenhouse vehicle. And in return, we can refine our solutions in a way that we can maximize the benefits of using electric vehicle, as because it's an essential goal for implementing electric vehicle is to reduce emission and to achieve our global warming degree commitments that in the globe. And on top of that, we are also recently launched a new project which we're collaborating with our stakeholders, with our partner organizations to address those solutions that we identify here and to help to reduce the transportation sector and electric sector emissions. And we also welcome any of like interested personnel or organization that want to know more information, that feel free to reach out to me and also reach out to our team for the progress and for the results or the findings that we identified in the project. In all, that when a framework, when we look at how to decarbonize transportation, it goes from a base foundation or scientific foundations. How can we identify the behavior? How can we identify the demand? And then goes to how can we optimize the supply such that it provides a palatable pathway for both providers and for both individual passengers and users. And ultimately, we integrate the cross-sectional, the interdisciplinary knowledge to provide a system-level infrastructure strategy and to provide a new knowledge and findings that's through the pathways. And this comes to the end of my presentation. Thank you.
All right, before we open it up for questions, I made the error of not acknowledging Sask Power. We thank Sask Power for their support of this series, and we also thank the audience for attending. So with that, are there questions for Kelly? Go ahead.
So, Dr. Penn, do you look at home charging patterns? Because the research shows that about 80% of EV owners, they charge their vehicle at home. So is that likely that you will see QA congestion in the city of Medina? Because we still have a very low adoption rate in Saskatchewan. It's about 2% last year. So would your study take into account of home charging patterns?
Yes. So our project actually, or the collaborative research, actually we will consider both electricity sector and transportation sector. So when we look at the electric sector, we're looking at also the residential charging behavior. And we do observe that there is a surge for the residential charging when people have the electric vehicle. And then this could bring the solutions of how can we create a more robust electricity, which actually some of our colleagues will address these issues in the May 25th symposium. Thank you.
Other questions?
All right, thanks for the presentation and set a question. So in the Department of Economics, I think about the economics of it and the role prices might play. And I wonder that the video is Tesla superchargers. Are they free to charge?
Supercharging center. So those are not free for charge.
Okay, you
Yeah.
have to pay.
Yeah, so they're going to pay.
So I just wonder if like dynamic pricing might be the solution here, where just like an Uber, when a lot of people want to use an Uber, the price goes way up. Like if you have a charging station, the prices are dynamic. You start to move people to the less congested places. Is
Yeah.
that something, I saw prices in your model, so is that something you're considering?
Yeah, so that's a very good question. Yes, that's definitely one of the strategies or one of the solution that we were going to investigate. And especially that how the electricity pricing should be optimized based on the electric vehicle usage. And also that on top of that is that how can we finance the infrastructure in a way that, because currently the gasoline vehicles, we have the road infrastructure maintenance or construction. Some of these costs are kind of considered in our fuel tax. And in the electric vehicles, that the sustainable finance between the government, between the service provider and the tax returns, those are also one of the key that also one of the key area that are currently investigated in not only in Canada, but also in global, that provide, you know, a sustainable and beneficial way. Thank you.
Question in the corner?
The government of Saskatchewan announced recently, I think today or the last couple of days, that they're not going to sort out the grid or electrical production in the province until 2050. So does that, what is the bearing? Like my first reaction was, well, that means we can't really proceed on electric vehicles because we're not going to have capacity until 2050. So we really have to sort of slow walk all of this funding and stuff in electric vehicles to line up with the 2050 goal instead of the 2030 or 2035 goal that the rest of the planet's doing. So can you comment on that? Have I interpreted that correctly, that we really can't get carried away with this because the province is going to be ready until 2050?
So so generally, when we are looking at a specific provincial strategy, so this could relate it to, like, one side is the demand, it's people's willingness to purchase electric vehicle. And what as you see the national picture that showed before, nationally that there is increasing of the electric vehicle demand. However, in Saskatchewan, that I don't have that figure, so I cannot speak for what kind of demand, electric demand we have, but this could comes to both the interaction between the demand and the supply. And at the supply side, that when we look at infrastructure, the infrastructure could come from how many people are going to use electric charging, and then this back to the interactions of the demand. And the second one comes from what will be the finance, a sustainable finance pathways. Like I answered for the previous question, is that when we adopting the electric vehicle, currently, how can we connect electric vehicle, this industry benefit to the road infrastructure, construction, maintenance, and sustainable development? So the connection between the finance way is maybe also one of the things that the provincial government may want to look at, because our current transportation road infrastructure is that in the provincial road infrastructure are responsible by the province government, and the national road infrastructure are responsible by the national government of Canada. So from the finance perspective, every province that may want to find their own, or could be the unique, or could be a shared pathways to how to promote and adopt the electric vehicles.
I can actually just comment a bit on uptake in Saskatchewan. We've done some total numbers on it. The uptake's not nearly as significant as it showed there. It's more like a 1% of vehicle range right now. However, somewhat anecdotally, somewhat actually, speaking to dealers, the problem isn't that people don't want them, it's that we can't get them. The city of Regina, for instance, would be buying several more electric vehicles if we could. We just can't get our hands on them. So we're selling for things like plug-in hybrid electrics and things like that, but the registration numbers aren't the same as what we see out there in, say, Toronto and American access and really neat interactive maps. That takes way higher in the east, but it's due to demand availability, not demand is very high in the province right now.
Yeah, so availability then, yeah, so the availability is comes from the manufacturers, right? So the supply from manufacturers. And this also one of the supply is that when electric vehicle providers or manufacturers, if they want to send a vehicle, they may want to send a vehicle. Sometimes they want to also look at where area has a high demand so that they can sell it fast. They can sell it in a good way. So that is also interactions for that. But also that I also suppose that when we have an increasing demand that can be noticeable by the manufacturer, this will ultimately increase the supply. That's from that perspective as well.
The question there.
Yes, my question is about the total kind of impact of adopting EVs. Right now in Saskatchewan, we have a dirty electricity grid, and you know the previous questioner was asking about or was commenting on the fact that now our government is pushing it down the road even further to clean the electricity grid. So is that something you're taking into account? Because you know, if we all adopted EVs, but we have a dirty electricity grid, it's not going to reduce greenhouse gases as much as if we first clean the electricity grid and or do both.
Yeah, so this is actually also one of the objective or targets that we want to work on that relate to the electricity sectors for what is the energy resources we're going to use, right? So are we still going to stay with our oil or the coal, or we want to change to more clean energy resources? And definitely that emissions that from the different energy resources can be different. And that is also that our ultimate goal that we want to identify and quantify what will be the emission reduction with electric vehicle, considering from the end to end. From the end, that is clean energy, that is energy resources, to the end, that is the travel demand.
Sorry, I can't see my words. I can add that the city has been operating at 450 for quite some time now, and the initial numbers that are in on it over winter, which is the worst performance you've ever seen out of electric vehicles, perform extremely well. The energy costs were about 10% of that if we had used gasoline as opposed to electricity. And the emissions were at least 30% lower than using gasoline. So even with the grid on the screen, we'd like to see it. The emissions are far below this one just due to the efficiencies we see in those electric vehicles. They're extremely cheap to operate and good for emissions. The upfront capital cost is where, as we see higher production, we should see the cost coming down.
Yeah.
I have a small question. Do you have any future research application regarding marine transportation? Because my past career, I'm a naval officer. So, like nowadays we have 30% reduction in decarbonization. So, if you have any research project on the future, like any application for marine transportation?
Sorry, to which transportation?
Marine transportation.
Marine.
Autonomous vessels.
Marine transportation.
Yeah.
Yeah, so we currently are more looking at the road infrastructure, but definitely marine transportation, to my knowledge, because I'm collaborating with some of the colleagues in marine, that they are also one of the transportation mode that has the highest unit emission per unit, and the highest emission per unit is marine and the air, and then comes to the rail. So definitely marine, what I know is that it's also one of the area or the domain that are pushing forward to the decarbonizing and reduce emissions. And I'd be happy to discuss with you further that for the details.
Question?
Oh,
Oh, sorry. Okay.
My just question's on battery maintenance and like the preconditioning. What kind of usage are you seeing? Like the preconditioning batteries and the requirements for that?
So you mean like how we consider the battery maintenance?
Yeah, like in the winter, kind of keeping that battery warm enough to.
Yeah, so so battery maintenance, we have identified some practices that from from what's the common solutions for that, but definitely that we are looking for more scientific with evidence-based solution for that. So for the practice-based solution, that some of the electric vehicles that they do have a kind of a coat that can keep the battery warm, and some solutions provided by the supplier is that that even that electric vehicle is not using in winter, probably due to charge, so that the battery is not reduced too much. And sometimes it's mandatory or it's necessary to charge the electric vehicle even it's not used, because battery even is not used, you're going to reduce as well. So and it is also worse that we have one of the tasks that we look at that. One of the research topic that we're going to look at how the battery, what is the curve of the battery lifetime.
Okay, go ahead.
From an infrastructure perspective, thinking about the installation of the charging station, is there any, like, as technology improves and as the cost should come down for faster charging, can you comment at all on any benefits or risks of installing chargers now at higher costs that can come down later? Does installing a level 2 charger, for example, kind of block out then upgrading that?
Yeah, that's a very good question actually, and that is one of the main direction we want to look at is, when we are at the early or medium stage, especially when we are at the transition stage, in the one time that we need to accommodate demand. On the other side, we want to look at the sustainable or long-term goal, and definitely that there are advantages and disadvantages. So a good thing that if we install sufficient chargers at this stage is that we can accommodate the demand we have, and also we can promote the demand. In the meantime, we can incentivize people to adopt or to use the electric vehicle because they see that it is convenient to use it, right? So it is accessible to use it, and this is extremely important for the passenger transportation and also for the freight or truck drivers. Because truck drivers may be more concerned about the electric charging, when and availability of the charging part. And so this is the benefits that we install, or we have a supercharger which can reduce the time compared to the L2. L3 can reduce the time, although it's expensive, but the trade-off will be that at a long-term goal, that we might need to trade off between the cost and between the charging time, and also considering the incentive of considering incentivizing the demand for achieve our goal on that. And we actually want to also look at how to quantify this benefit, that is cost benefit analysis that we're going to conduct is to quantify and qualify what is the trade-off between considering different sectors, considering different stakeholders' perspective.
Okay, I think maybe last question maybe.
Just sort of, if I might follow, I'm making the assumption, I read this somewhere, that the average passenger vehicle travels about 20,000 kilometers a year, which works out to about 55 kilometers a day. And I appreciate that simple math. So some days it might be 100, other days it may be 10. Have you calculated out in terms of clean energy, how many solar panels on a roof it would take to charge a vehicle from 95% or whatever 50 kilometers off the battery creates, so that you could in fact charge your vehicle from the solar panel, and if it only takes 2 or 3 or 4, have you looked at that kind of analysis?
Yeah, that's actually a very good question. So because during the way that when we identify those possible solutions, right, energy resources to charge electric vehicle. It could be from the electricity, it could be from the solar panel. And now what we're currently looking at is from solar panel, from the electricity, but definitely at least we know that in the city or in Regina, that some residential areas do install the solar panel. And from the electricity provider's perspective, that these solar panel energy are not well paid back. So it can be incentives for people to utilize those some redundant or those solar panels created in their residential area to charge their electric vehicles. But then something that we need to investigate more is that what is the safety that compared to the charging, and also how much this can be done considering the installation of solar panel, consider efficiency of the solar panel to charge the vehicles. And there's still a variety of the unanswered questions, which I think that is worth to investigate as well.
All right, really good. So I'm sort of really pleased to see the number of questions and the discussion that has gone on today. As Kelly has indicated, we are going to have a symposium on decarbonizing transportation on the 25th. We really hope that everybody will attend and will tell their friends, and that we will have a good deal of interest and participation. After that symposium, we're actually going to have some kind of a reception in one of the classrooms just on one side, with the goal really to try to have sort of more one-on-one communication between the audience, and maybe try to work on finding things that we could attack together, research projects, experiments, study proposals, that sort of a thing. So we're really trying to have the presentation and that portion of the discussion, but we really feel that there are going to be more questions asked than there are going to be answers at the symposiums or at this seminar, for example. These are just still open questions, and what we're trying to do is get people talking and communicating and creating mechanisms whereby those questions can be answered, and we can move towards some kind of a solution. Because I see it's obviously just buying electric vehicles is not going to solve the problem. Where are we going to charge them? What are we going to do about the congestion? What are we going to do about the power supply, the energy sources that we're going to use? There are just so many questions here that we need to address before we can move to satisfactorily to this lower carbon future. But I would like you to join me to thank Kelly for a very good. Thank you so much for coming today.